Hello class, today I'll be showing you how to graph the first and second derivative of function 7, this one right here. Uh-oh, this isn't the right graph. This is a graph where the highest exponent is 4. Oh, that's the correct graph. This is a graph of the absolute value of a parabola. Now to graph the first derivative of such a function, let's refer back to a normal absolute value function. Absolute value of x. Over here, you can see the function of the absolute value of x. Over here, I put dotted lines and this solid line here to represent the original function x. And over here is where the function was flipped. Now, alternatively, you can also see the absolute value function as a piecewise function where when x is greater than 0, the function is equal to x, and when f is less than 0, the function is equal to negative x. Now, to see how it affects the derivative, over here, the dotted line and the solid line here, again, represents the original function, x. And over here is where it's been affected by the absolute value function. Because over here it's been flipped over the x-axis, you can also do the same in the derivative. Now, using that knowledge, with a parabola, we can assume that from negative infinity to 0, and from 0 to infinity, that it'll be like the normal function inside the absolute value, and the part over here that's been affected by the absolute value will affect how it looks on the derivative graph as well. Now, following the method over here with the normal absolute value function, we're going to draw it normally. Except at the points where it's been affected by the graph, we'll put those as dotted. And then over here, it resumes to be the normal function again. So we'll put this as a solid line. The reason why this linear function is translated 1 to the right is because over here, the derivative of the function has a relative extrema, or relative maxima, at x is equal to 1, where the slope is equal to 0. So we wanted to make sure that the graph passed through the point at 1, 0. Now, just as we did, or just what happened in the absolute value function, where the derivative was flipped over the x-axis, we'll do the same over here. So where this portion here is at 2, we'll put that over here. And where this portion here is 2, or where this portion here is negative 2, we'll put that over here. And have a straight line through. Now, because over here we have cusps, the derivative isn't defined, which would mean that on our function over here, the derivatives at the cusps, or x is equal to 0 and 2, would also be undefined. Now, the solid lines, which I will put into with a different color, are our first derivative. Now, using the same process over for the second derivative, we're going to be doing the derivative of the first derivative graph, which is a constant slope, which would mean that the graph of this function would be a horizontal line. Now, graph the original function, a solid line for where the graph is normal or unaffected by the absolute value, and dotted where the function is affected by the absolute value. Now, 0 to 2 is affected by the absolute value, as shown here and here. So we'll flip that over the x-axis. And because it's not defined, or there is no slope, or it's undefined at x is equal to 0 and 2, we will have open holes at x is equal to 0 and 2. Again, I'll highlight in a different marker. Now, if you did it on paper with pencil, you can just erase the dotted lines. That is how you graph function 7 and its first and second derivative.